In this video, I'd like to talk about units that have exponents specifically. This can sometimes complicate a straightforward multi-step dimensional analysis problem. And it really comes down to building conversion factors. Sometimes we'll be communicating volume in terms of length cubed, like a centimeter cubed is equal to a milliliter. They both represent the exact same volume. So if we are dealing with a conversion factor where we know we're converting from one unit of volume to another, but we don't have a conversion factor for it, we can build that conversion factor from its base units. So here, if I want to know what the volume of something would be in inches squared for area versus centimeters squared, and I only know that 2.54 centimeters equals 1 inch, I need to build a conversion factor that will take into account that we're squaring our units for area. And so I can't use just our straightforward one for length. It's different. What I need to do is say, okay, well, we start with our length, and I know I want area, so I need to have both sides squared. And so we raise both sides of the equality to the exponent that we're interested in. And then we're going to distribute that exponent out to the unit and to the numeric value. And sometimes it's easy to forget to do this piece. And so I'm going to then end up with 2.54 squared centimeters squared is equal to 1 squared inches squared. And on this side, it simplifies nicely to 1 inch squared, but my 2.54 squared is really 6.45 centimeters squared. And so we have a very different value for our centimeters squared to inches squared conversion factor than we do for centimeters to inches. And this is sometimes an easy thing to forget when you're going through a difficult problem. So give this one a try, and then I will do it as an example. You can pause this video, give it a try, then restart it. I'm just going to walk through my solution for it here. Okay, so we've got a cube sample of lead, or iron. That's not lead. Lead would be PB. And we know it has dimensions of 3 by 5 by 5 millimeters. And it weighs 0.85 grams, and we need to calculate the density in terms of units of grams per centimeters cubed. So density is equal to mass divided by volume. I've got this mass, it's equal to 0.85 grams. I now need to find volume in terms of centimeters cubed. So I'm going to start by calculating the volume of my cube of lead. So the volume of the lead is going to be equal to 3 millimeters times 5 millimeters times 5 millimeters. That's going to equal 75 millimeters cubed. If I've measured this, I really only have one significant figure though, right? So I'm going to underline my 7 right here and keep all of my digits moving forward. But if I were to stop at calculating the volume in millimeters cubed, I would round this up to 80 millimeters cubed. We'll just underline for now. Okay, so now we need to convert that 75 millimeters cubed into centimeters cubed for our problem. So I'm going to want my centimeters cubed on the top and my millimeters cubed on the bottom. And to plug in that conversion, I don't have it. I do know that 100 centimeters is equal to 1 meter, which is equal to 1,000 millimeters. I can reduce this and say that 1 centimeter is equal to 10 millimeters. But that's just in one dimension. So I would have to cube this whole thing on both sides of my equality. And then I would distribute that 3 out to both the unit and the value. So I would have 1 cubed centimeter cubed is equal to 10 cubed millimeters cubed. Now that's going to reduce down to just 1 centimeter cubed is equal to 1,000 millimeters cubed. Now I have a conversion factor. So that 1 centimeter cubed divided by 1,000 millimeters cubed will be my conversion factor. My millimeters cubed should cancel out, leaving me only with units of centimeters cubed. And when I plug this into my calculator, I'm going to get 0.075 centimeters cubed. I'm going to again underline that 7 to remind myself my significant figures that I have in this problem. I only have one so far. And now I can take this value and plug it in up here into my density equation. So that's going to be 0.075 centimeters cubed. And I can plug in to my calculator and calculate density using this equation. And when I do that, I get a value that is 11.3333 grams per centimeters cubed. So I have 2 significant figures for my mass, and I have 1 significant figure for my volume, and I'm dividing them, so I'll keep the least number of significant figures, which is really then just 1 sig fig. So I would report this number by rounding down to 10 grams per centimeters cubed, which doesn't feel very accurate, but I did not have a very accurate way of measuring length.